Am I audible on the back side? Not many people on the back side, but am I still audible? So, good afternoon, ladies and gentlemen. First of all, I'd like to thank ICTA for choosing the topic of recovered fiber with a backdrop of quality. At BSF, we always associate consistency with the quality. Achieving quality is not very difficult, but staying at that particular quality, maintaining the quality or getting the consistency in quality is a difficult task. So we propose a topic of achieving consistent quality in coated packaging board, which is made out of recovered fiber. And here we will be talking about certain innovations which we have done for paper coating latex. So I will take you all through these three topics. First, we'll take a deep dive on coated packaging board, which is made with recycled fiber. We will see its structure, what are the key market needs, what are the challenges we face in using recovered fiber on day-to-day basis, and certain remedies which can mitigate the challenges mentioned above. So let's see the value chain of recycled board. So we are at a paper mill level. From here it goes to printer, then it goes to brand owners and consumers. So finally consumers like me and you or the people outside will be highly influenced by the packaging itself. So the brand image printed on the box, the packet design, how easy is to handle that particular packet. Overall print appeal makes a big difference. Suppose as a shopkeeper, I pack same shirt in two different boxes. So we highly likely will buy shirt packed in XYZ box because the box looks much better in print quality and it doesn't have those missing dots like these white spots you see. So what point I want to make is recovered fiber is a big challenge itself because it varies a lot. We have heard since morning many speakers talking about the variations in recovered fiber. Since the decision making of a consumer is highly influenced by the printing of the box, so we really have to take care when we are doing it with recovered fiber. So with recovered fiber, I have listed down some of the challenges. Degrading furnish, we don't know how many times the recovered fiber has been already recycled in a mill, so it might be its fourth or fifth turn. Then it leads to inconsistency in quality of the board. Our box making machines are now ever highest. Maybe 10 years back it was the slower one, but now it is much faster. The box needs superior printability. Because of sustainability these days, recovered fiber is fighting with boxes made out of virgin fiber board. Sustainability, of course, it's forcing us to recover and recycle more and more in our mills. And of course, runnability and cost in use because of competition, the competition is ever highest these days. So we really have to work on reducing the cost at our end. So now we'll take a deep dive in the structure of a duplex board, the coated board made with recovered fiber. So here you see the base board. It has got generally 4 layers. It could be 7 layers also if the mill is based on molds or formers. So basically, generally there are 4 layers: top layer, under layer, filler layer, and back layer. So what we do in coating, we generally provide 2 coats on top, pre-coat and top coat. Of course, there are mills with triple coat also these days, but generally it is double coated. And on the back side, we apply a single back coat. So if we focus on this area, which is the joint of top layer with pre-coat as well as top coat, if we expand it say 2000 times what we see, we clearly see a baseboard. This is probably the top layer which is visible now, and on top of it you can see a pre-coat which is having coarser pigments of carbonates basically, and in top coat you can clearly see finer pigments which are basically clay and carbonate, finer ones. And here these places you see certain capillaries or pores. So let's take a deep dive in these pores by clicking a photo of the surface of the paper. So what you see here is the surface of a paper which is uncoated. You will see some pores and capillaries as black areas. Paper will always have capillaries because it is not plastic. There would be some pores in it every time. But the problem what we have with recovered fiber is the variation in these pore sizes or the length of the capillaries. So these variations will come due to the type of recovered fiber we are talking about, whether it is a duplex board being recycled, or a newsprint being recycled, or a writing printing segment after a kid has written on it using a ball pen or a gel pen, whether that particular fiber is being recycled. The morphology of initial fiber. By initial fiber, I mean the first fiber by which the paper was made. Then varying ash content. Sourcing country also plays a big role. But unfortunately, we can't avoid these variations, so we can mention them as the inherent unavoidable variations. We have to live with this. The challenges which come in the form is pore size and capillary size changes. This leads to a lot of migration. If you apply a pre-coat on a coated surface, through these capillaries, the water from pre-coat will tend to migrate into the baseboard. And along with the water, it will take away binder, it will take away other water-soluble ingredients of coating color into the baseboard. So what it leads? It leads to inconsistent coating coverage and poor strength. Sometimes my strength properties are very good, sometimes my strength properties are not so good. And finally, it is our customers, the end users, who is going to make a complaint in terms of dusting or mottling in the final print. So what we concluded is that improved water holding capacity of a coating color can mitigate some of the above challenges. So now we understand that water holding capacity is something which is really important for coating color, especially for a coated duplex board made out of recovered fiber. And today morning we heard that until we observe, until we study, we cannot control. So as BSF, we chose two properties or two equipments to study the water holding capacity of coating color. The first one is antenna par. This particular equipment gives the viscosity of coating color with time. So what we basically do, we fill coating color in this cavity. You can see blue color is the coating color. And below that we keep one standard base paper, and below that we apply vacuum. So basically through this vacuum we are sucking water from the coating color, and there is a mechanism which checks the viscosity of this coating color. So there is a graph plotted in the equipment itself. So with time the viscosity of coating color we keep on increasing because we are removing water from the coating color. At one point of time this coating color becomes so thick that it can't move. So that is referred as coating immobilization time. So on x-axis we have time, and on y-axis we have viscosity. So basically with time the viscosity goes up and it goes to a point where it can't move further. So in coating color what we need is a higher immobilization time. So higher the immobilization time means the coating color is not going to lose water that fast, which is a requirement for these. I would like to share studies results of pre-coat as well as top coat. So which is as follows. So here you can see we took one conventional latex and we took one development grade which came from our R&D department. We kept the recipe same, absolutely same. We just changed the latex grade. Then we see what are the coating color properties. So in case of conventional latex and development grade, everything is same except gradic water retention. So in development grade we are getting much lower water retention values under gradic. So this is what we wanted to achieve. And in terms of antenna par, again the coating immobilization time, if you follow the development grade graph, the coating immobilization time is close to 170, which is much better than the conventional latex which we used for the comparison purpose. Now we go to top coat. Quite similar observations. So top coat recipe is a bit different. It has got some clay, of course, for better smoothness people intend to use clay in top coat, and certain other additives also. So again it is just apple to apple comparison of conventional latex to development grade. So let's see the coating color properties. So here with same level of viscosity, same level of solids and same level of pH, we got much better water retention values. In case of conventional latex it came around 90, and in case of development grade it came around 68. And let's see what happened in antenna par. So here again as expected we have much better values of water say coating immobilization time, much higher numbers in terms of seconds for development grade. and conventional latex, as expected, gave lower time for immobilization. So now we were ready with the two pilot type of products. One is suitable for pre-coat, another one suitable for top coat. Then we went for extensive studies. So now I am almost at the fag end of my communication in this occasion. So what are the conclusions we can draw from these technical experiments? So we did extensive studies and the results are really repeatable. So it showed repeatedly on Gradec as well as Anton Par that the development grade is showing us much better water holding capacity of coating color. So what we did, we quickly prompted and we took it to various paper mill real trials, and we were able to meet customers' expectations. How we came to know? Because with this, the complaints of customer from market, especially on, say it is related to picking or dusting, or it is related to mottling in the paper, that came drastically down. So these kind of latexes are already in the use at various paper mills. Conclusion on a broader paper industry level, a key challenge in using required fiber is to maintain the consistency in quality, whether it is newsprint or whether it is writing printing or craft, whichever paper you refer. If we are using required fiber, there is a challenge of maintaining the consistency in quality. And when we talk about the coated duplex board, the challenge is much higher because generally these boards are printed with rigorous print requirements. The duplex board can be printed as high as 10,000, 11,000 impressions per hour in offset printing process. As well as it has to go through a lot of converting processes also, like lamination, gluing, metallic foil lamination. So it really goes through a lot compared to other paper made out of required fiber. So the challenges of coated duplex board is a bit higher than the regular paper like newsprint or craft. So to accommodate this, paper industry must embrace newer technologies, and they are doing it. So as we heard in the morning from Khanna paper that they have gone for various technologies to incorporate more and more required fiber into their system. And now I'm at the conclusion of my communication this day. So at BSF, we remain committed to support paper industry generally so that we can support our customers to get more and more commercially as well as technically successful solutions. Thank you all.